So SUN matrices act on complex, vector spaces, right? SUN acts on CN. So these are the vector spaces they act on. But they can also act on C star of it, the complex conjugation. And they are independent vector spaces. So the matrices in general, the matrices say that suppose this is a matrix and U acts on, say, some vector in Cn. What is Qi? Qi is a set of complex numbers. Okay. So suppose U acts on QiCn. Okay. And U star acts on Qi star. Okay, where this is complex conjugated. The thing is, for SUN with n greater than 2, there is no similarity transformation taking U to U star. Such a transformation does not exist when n is greater than 2. For n equal to 2, it does exist. Okay, so Qi, they are called the fundamental representation of SUN, and Qi star, which is sometimes written as Qi bar, they're known as the anti-fundamental. Okay. Mathematicians might call it differently, and they might call it conjugate or something, but physicists call them the anti-fundamental representation of UN. And in the next class, we will see how you can take tensor product of Qi with other Qi, or Qi with, say, Qj bar to get new representations. And this was something which is very important in particle physics, because Murray Gell-Mann showed, assumed that the quarks, there were 3 quarks, up, down, and strange quarks, and he assumed that the strong interaction had an SU3 symmetry, and then he constructed, particles like made out of quarks, which are bound state of quarks, by taking cross products of, different numbers of representation, and he was able to predict. He was able to explain a lot of the particles that were being seen in strong interaction physics, as well as he was able to predict the existence of a new particle, for which he was given the Nobel Prize. Okay, so in the next lecture, we'll talk about SUN and the fundamental and anti-fundamental representation, and how we can construct bigger things, more interesting representations from that. Okay, so that's where I want to stop here, and let me just take the attendance quickly.
So the standard model thinks every force should have a particle carrier and trying to find the graviton. So what is the basis of this decision that every force should have a particle?
Oh, this is just quantum mechanics. Quantum mechanics has, in terms of, quantum field theory tells us that that should be the case. But string theory doesn't agree with that, right? I mean, graviton should exist. I mean, there is really very little doubt that there should be something called a graviton. Although, I don't know, there are some school of thoughts where they think of gravity as an emergent force, so they might think differently. But the reigning prejudice, if you like, is that every force should have a quantum, a particle carrying quantum version of it. Okay, Rahul, are you there?
Yes, sir. Okay.
Good. Zabir? Dipro? Okay, Medat? Yeshan?
Present, sir.
Shujosh? Sitima?
Present, sir.
Audrey? Saif? Saif is there. Abdullah?
Yes, sir.
Nahi is there. Fiza? Fahim?
Sir, I'm here. Sir, I'm here.
Yes, sir.
Okay. Fahim is there too. Fiza is there. Farhan is there. Oishik Khan? Hassan? He's never here. Proma?
Yes, sir, I'm here.
Okay, so yeah, let's, the formal part of the class is over, but I'm here for questions if you have any.
Sir, when might we have our finals?
Yeah, that's a good question. I mean, we have to decide on that, right? So when does the Eid vacation end? And let me pull up the calendar. I have to be very careful when I move my chair because there are two very soft kittens living in this room. Okay, let me look at the Brachyur calendar. Okay, so final exam week is from the 8th to the 14th, right? So any of those days, I mean, I was just thinking maybe I can give you on a Thursday evening and you can try it on Saturday morning. Well, how does that sound? So I post the exam sometime on the evening of say 12th, and you turn it on the 14th, the Saturday morning.
That sounds good, sir.
Okay. How about other people?
I'm okay with that.
All right, so I will see you guys for the last time officially in the next on next Wednesday, right? Okay, any other questions? Before you go, I wanted to say something about the tutorial. There was a technical mistake in the statement of the tutorial. I claimed that the continuous representations were irreducible, but I spoke to Hasib since then, and he told me that they are not. That's not the case. That the continuous representation can be written as in terms of sums over an infinite number of finite dimensional representations. So I'm still learning the mathematics of it. So at some point I'll just post about that, okay? Saif, you were gonna say something.
Yeah. Something about today's class made me confused about what exactly is the representation in the representation. Like, is it the Rij, which is the representation? I'm not exactly sure, like for SO3.
Right, that's a vector representation, but when it's acting on say F, say Tij, it's going to be some bigger matrix Rij, KL and some combination of indices, right? Yeah. You can work that out. What that matrix, it's usually, if you work out what this is, the antisymmetry of this makes sure that the components of this which are not needed drop out of that already. Okay, because you can show that under transformation, this actually does go to another matrix which is still antisymmetric. Okay, and that's going to be RIL, RJ, K, and then we have TLK antisymmetrization. But as I said, if two indices are antisymmetrized, whatever contracts with them is also antisymmetrized. So that means this is antisymmetrized, this is antisymmetrized, this is not. Okay, so the object that is acting on this thing should be a four-headed monster, right? Because there are two indices here, there should be four. So that thing, let's call it R tilde. R tilde IJKL is defined to be R of I, antisymmetrization with J, another factor of R, K is not antisymmetrized and L is antisymmetrized. Okay, so these are the matrices that will act on this vector space. That's a very good question, Saif.
Oh, actually, I got confused, like when you were saying SO3 acts on R3 as a vector space. So I was wondering whether the vector space is the representation or the matrices are the representation.
The matrices are the representation, but by an abuse of language, we identify those.
I see, okay.
Yeah, that's a very, very good question, and I should have clarified that. So they're kind of, used almost interchangeably. Here, I'm talking about the space on which SU3 acts, right? Not SU3. But of course, the object that acts on this is not going to look like my 3x3 matrices.
Yeah, I see.
There will be bigger representation. We know that there are higher dimensional representation of these groups, right? So, you will find this object in one of those higher dimensional representations, irreducible representations. And that's you can develop these things in a very formal way. There's a whole formal architecture for doing that. And what I'm doing here, giving you the delta function, the Kronecker delta and the Levi-Civita tensor, those are the tensor methods that are used to make these things. There are other more sophisticated methods such as Young's tableau. But we don't have time to learn about Young's tableau. But you should know that those things exist.